Math 3, Unit 2, Section 5. Today we're talking about solving and graphing quadratic equations. So we've talked about a few different methods of solving quadratic equations. The most recent one we talked about is solving by square roots, although the way they set this one up is not exactly how we learned it, so I'd like you to cross that out. At this point right here, what would we do next? We would take the absolute value of, take the square root of both sides, and then we'd have the absolute value of x minus 3 equals root 3. And then when you set up the two equations, you end up getting to this point, right? And so we'd have x minus 3 equals root 3, and x minus 3 equals negative root 3. And when you solve those, you would end up getting 3 plus or minus root 3. We also learned about solving by factoring. Okay, the first thing you always want to do is make sure it's set equal to 0. They have skipped a step here, but at this point we would have gone, my multiplication number is 10, my adding number is 3, and then the numbers that you end up getting that work are 5 and negative 2, which is where they took the shortcut and went right there. And then went through and solved. Today's the first day we're talking about the quadratic formula, although yesterday you guys simplified problems with the quadratic formula. Most of you have seen this before, but here's your quadratic formula. If you do not have this memorized, you can borrow a note, or not borrow, you can have a note card from me, but you need to have this memorized. This is a formula you will use throughout this year. Okay? The one thing though that you always want to make sure is that your equation is set equal to 0. Okay? Your A term is always with your squared term. Your B term is always with the plain x term, and your C is always the number that doesn't have an x with it. But it only works if it's set equal to 0. Because see right here, you think your C value is positive, but it's not. It's actually negative. So make sure it's set equal to 0. If you are missing a term, like let's say there isn't a plain x term, then you would give your B value a what?
0.
A 0. Good. Okay, so we're going to go ahead and move on now and start with our examples. And we have been graphing lines a lot. And so we are going to be graphing two different equations here again, f of x and g of x. So g of x is probably the easiest one to graph. So this is saying g of x equals 0, which actually means what? Y equals 0. Very good. And so we are going to draw a straight line here at y equals 0. Okay, our next equation is f of x. And for f of x, I'm going to actually grab a different color. What is my vertex? Okay, so the vertex inside our parentheses with our x, the x value of the vertex will be negative 3 because we'd set that equal to 0 and find that it equals negative 3. And then my y value is the value at the end, which is a positive 4. Do we see that? Okay, positive 4. So on our graph, we're going to go left 3, 1, 2, 3, and up 4 and make our point. Now, can I use slope on this? No, why not? Good, it's a quadratic. It has curved lines. Okay, anytime we have curves, we have to plug in points. If it's straight lines, we can use slope. So, what would be some good values that we could plug in here? We could plug in 0. We could find out where it's going to be over here. We could plug in -1. We could plug in -2. So I'd say all of those values are good values to plug in. So should we just try 0 and see what happens? Okay, great. So if I'm plugging in 0, we are taking this equation right here, and we have y equals negative, and I'm plugging in 0 for x, so that is 0 plus 3 squared plus 4. Yes? Hold on. I can't hear you. Say that one more time.
Isn't it basically solving the factor?
Yes. We're going to get to that in just a minute, okay? We're going to graph it first. All right, 0 plus 3 is 3, and then 3 squared is 9. Okay, and so this ends up being 9. So we end up with negative 9 plus 4. And what is negative 9 plus 4? Negative 5. And so at 0, it's where? So the point is at 0, negative 5. So 0, negative 1, 2, 3, 4, 5. And then over here, since this is 1, 2, 3 away from my vertex, we go to the opposite side of the vertex, 3 across. Does that make sense? You guys remember that? Yeah. So we're going to go 1, 2, 3, and this way. Now, we want to know exactly, I can draw this and kind of see approximately where it might be crossing the x-axis. But the easiest way to tell for sure is by solving it algebraically. So we're going to do what Lavina said, and we are going to go ahead and solve this algebraically right now before I finish graphing this. So f of x, we're just writing what f of x equals. In this case, it is negative parenthesis x plus 3 squared plus 4, and that's my f of x side. And then what does g of x equal? 0. Okay, and this is what we went through yesterday. What will I do to end up solving this? What do I need to do first? Good, subtract 4, because we want the square by itself. So we subtract 4 to both sides. Negative parenthesis x plus 2, x plus 3 squared equals negative 4. Is the square by itself? No. What am I going to do next? Very good. Divide by negative 1 to both sides. So the negatives cancel out. A negative divided by a negative is a positive. And we get x plus 3 squared equals positive 4. Good. So now my square is by itself. What am I able to do? Very good. Take the square root of both sides. So the square root of x plus 3 is going to be written which way? Very good. Absolute value of x plus 3 equals, and the square root of 4 is 2. What's next? Very good. Set up 2 equations. And what do we get? X plus 3 equals 2. Remember that this side doesn't change at all. It's the answer side that can change. So we have a positive 2, and then the other one is a negative 2. And we solve. Here I subtract 3 to both sides. X equals negative 1. Here I subtract 3 to both sides, and x equals. And so what's happening is that this quadratic is crossing at x equals negative 1 and at x equals negative 5. So if I had plugged a negative 1 in here, we would have gotten 0. Okay, and so this is what my quadratic equation looks like. When y is 0, it's crossing the x-axis at negative 5 and negative 1. And algebraically, again, here we can see that x is equal to negative 1 and negative 5 when y is equal to 0. Okay, and so these should look the same. They're giving you the same answer, but this answer is graphically and this answer is algebraically. Do you have any questions for me? Okay, does anybody need more time with this? Okay, let's move on. We're going to do one more example like this. Okay, so personally, I think it's easier to start with the algebraic side and then go back to the graphing, because then I don't have to plug in as many values. Does that make sense? So let's go ahead and start with the algebraic side this time, and then we'll go back to the graphing. And you know what I realized? I forgot to plug in. So what does x equal over here on example 1? Yeah, same answer, -1 and -5. Okay, this is when the two graphs intersect at -1 and -5. So that is where f of x actually equals g of x. Okay. So on this equation, same thing, we're going to write whatever f of x is, and in this case, f of x is what? Perfect. Equals, and g of x is 0. Good. Okay, we want to get our square by itself. What will I do? Good. Add 3 to both sides. Those eliminate. We have 1/3 parenthesis x minus 1 squared equals, and 0 plus 3 is 3. How will I eliminate that fraction? Good. Multiply by the reciprocal, which is 3 over 1. And whatever we do to one side of our equation, we have to also do to the other side. Okay, and you can write it as 3 over 1 or just 3. So that fraction eliminates. I'm left with x minus 1 squared equals, and what does it equal? 9. Very good. Okay, next, what would I do? Take the square root. Good. We take the square root of both sides. Whenever I take the square root of a variable, what does my answer become? Very good. Absolute value of x minus 1 equals, and the square root of 9 is 3. Now we set up our two different equations. So we have x minus 1 equals 3, and x minus 1 equals -3. Here we solve, we add 1 to both sides, and we get x equals 4. Over here I add 1 to both sides, and we get x equals -2. Okay, so algebraically my answer should be 4, -2. So now let's go and look at our graph. So again, our easiest graph to do here is our g of x, and that actually means what? G of x is the same thing as saying y equals 0. So we're going to draw our line through here at y equals 0. And I don't think I did this on the first problem either, but I would suggest that you label this as g of x. For our f of x equation, what is our vertex? Good. 1, -3 is correct. So I'm going to go right 1, down 1, 2, 3, and make our point. Now, looking at our a value, should this curve, should the quadratic be going up or down? Up. How do you know? It's positive, okay? If it was negative, it would go down. Here it's positive, it's going up. And then I'm not going to plug in values this time because I know that it's going to cross the x-axis at which values? 4 and -2. So here's -2 with a point, and here is 4 with a point. And then I would kind of double check it. So is this 1, 2, this is 3 away on this side, and then it's 1, 2, 3 away on the other side. So I can see it is symmetrical. Okay, and we're going to go ahead and draw our curve. And then what does x equal? Good. -2 and 4, or 4 and -2, either way. Okay, questions before we move on? Okay, so part of your homework is to solve them graphically and algebraically like this. And then the other part is where we're just going to be solving quadratic equations. And you're going to have to use multiple methods. So you either are going to use your grouping, you're going to use squares, or you're going to have to use the quadratic formula. Also, it says if there is no solution, write none. You're going to cross that out. If you end up getting a negative under the square root, does anybody know what that becomes or remember? Very good. So whenever you have the square root of -1, that equals I. And what happens is we normally just take that negative from under the root and bring it out and make it an I. So instead of writing no solution, we're going to turn it into an imaginary number. All right. So number 3, what's the first thing I should do? Is it set equal to 0? No. So because it's not set equal to 0, what am I going to have to do? Subtract 35, and then what else? Distribute. Okay, so I need to subtract 35 to both sides because I want that to be set equal to 0. Do you guys want me to make this bigger in the back? Yes? Okay. All right, and then we're going to also distribute. So what is x times x? X squared. X times -2. Good, minus 2x. And then I have minus 35 equals 0. There is nothing that is like terms that we would combine together. So when we multiply over by 1, my multiplication number is what? -35. And my adding number is -2. Perfect. Okay, are there any numbers that multiply to be -35 and add to be -2? Good. -7 and 5 is correct. Always double check. Yes, those add to be -2, and yes, they multiply to be -35. Okay, and then we learned that, can I use the shortcut on this one? Yes, and when can't I use the shortcut? Very good. When the number in front of our x squared term is larger than 1, or we can't use it. Okay, so that means we're going to make our 2 parentheses. Since this says x squared, we split it up in our parentheses. Each of these get an x. And then we have a -7 and a +5. And this equals 0. At this point, we have to still solve for x. And so what will my final answer be? Very good. X equals 7 and x equals -5. Questions before moving on? Okay, number 4. Is it set equal to 0? No. One thing also that we didn't talk about really, but you always want your x squared term to be positive. And so the x squared term is positive, so we want to move everything from the right over to the left. And so I'm going to subtract x to both sides and subtract 5. So those eliminate. And we're going to go ahead and write this out and combine like terms if we can. So here we have 6x squared minus x, and then 4 and -5 makes what? -1. Good. Equals 0. So factoring is always usually the easiest. So I always check to see if I can factor first. I'm going to multiply over, and so what is my multiplication number? -6, and my adding number is -1. Very good. Are there any numbers that work? Very good. 3 and 2, and then which one needs to be negative? Good, because we want the larger number to be negative in order to add and get a negative answer. Okay, and can I use my shortcut? No, good. Okay, so we're going to break this down. And so we get 6x squared minus 3x plus 2x minus 1 equals 0. Are there any questions about this? Okay, so now we're going to group them. What is the GCF of the first group? Good, 3x. And when I take out a 3x, what am I left with? 2x minus 1. There is not a GCF of that second group. So what are we going to take out? Very good. So you always want to write that 1 out in front, and then 2x minus 1. So that means now, how do I finally finish factoring this one? It's going to be 2x minus 1, because that's now my GCF. These match. I bring out the 2x minus 1, and my other parenthesis is, very good, 3x plus 1, set equal to 0. What do I do now at this point? Set each of those factors equal to 0. Okay, and I kind of ran out of room here. So 2x minus 1 equals 0. You add 1 to both sides, and you get 2x equals 1. We divide by 2, and so x is 1/2. Do you guys, can you do this one in your head? You would subtract 1, so you'd have a negative 1, and then you would divide by 3. If you need to work it all out, you can, but if you can do it in your head, that's fine. So you end up with a positive 1/2, and then this one makes a negative 1/3. Those are our answers. Any questions? Okay, number 5. What do you think will be the best method for solving number 5? Good, and specifically it's going to be solving by roots or solving by square roots, right? Okay, so we are going to start by subtracting 5 to both sides. We have 1/2 parenthesis x minus 3 squared equals 2. What will I do next? Good, multiply by the reciprocal, which is 2 or 2 over 1. And we do that to both sides. Eliminates our fraction. And I'm left with x minus 3 squared equals positive 4. Good. Yes? When you have like just a square. So when you have, see how this was set up as you had a squared term? Anytime you have a squared term, then you want to get the square by itself. So you know when, even like when you have your differences of squares, you could do factoring by differences of squares, or since you just have a squared term, you could actually solve it and just get the square by itself. So it's basically when you don't see a plain x term by itself. Okay? All right, what do I do now? Very good. Take the square root of both sides. Anytime I take a square root, I'm going to get what? Absolute value. So I have the absolute value of x minus 3 equals 2. Good. At this point, what do? Very good. 2 equations. X minus 3 equals 2, and x minus 3 equals negative 2. Okay? Here I'm going to add 3 to both sides, and I get x equals 5. Here I add 3 to both sides, and I get x equals 1. So there are my 2 answers. Any questions? Okay. Number 6. What do I need to do first? Very good. Set it equal to 0. How will I do that? Add 1. Good job. X squared minus x plus 1 equals 0. I have a 1 here in front. When I multiply 1 times 1, I get 1. My adding number is negative 1. Is there anything that multiplies to be 1 and also adds to be negative 1? No. So since this does not work, we are going to use what? The quadratic formula. Okay, so A equals 1, B equals negative 1, and C equals 1. So again, if there isn't any numbers in front of our variables, we can always put a 1 in front. So this was our A, This is our B, and this is our C. And again, it has to be set equal to 0. Okay, the quadratic formula is, I'm going to write it down here at the bottom under this homework part, but it's negative b plus or minus the square root of minus 4ac all over 2a. At another time, if you want, I will show you the video of them singing it too. Pop Goes a Weasel. If you were in my class last year, you got to enjoy that. So I'm not going to sing it to you right now, although I'm sure you guys would enjoy it very much, but at another time. So what is negative b? It'll end up being a positive 1. Because if you're doing a negative b, you're going a negative, negative 1. And two negatives side by side make a positive. And so when you see negative b, it means whatever b is, you're going to take the opposite of that value. Okay? Plus or minus the square root of b squared, so negative 1 squared, minus 4 times a is 1, times c is 1. All divided by 2 times 1. And notice that it's dividing that whole piece, not only the square root, but also that negative b value there. Okay? Also, this is saying x equals that value. So it's actually x equals negative b. Okay. So I always like to go through and simplify the root first, just like we did yesterday. What is negative 1 squared? 1. And then negative 4 times 1 times 1 is negative 4. And what is 1 minus 4? Negative 3. And then 2 times 1 is 2. So when I write this now, we have x equals 1 plus or minus the square root of negative 3 all over 2. Is there anything I can simplify here? Can I break the root down at all? No, but there is one thing I still need to do, and what is that? Very good. Take out the negative. So the negative under the root has to be brought out, and when you bring that negative out, it becomes what? I. So x equals 1 plus or minus I root 3 all over 2. One thing that this means is that there aren't any real solutions to this quadratic equation. Okay, there are only imaginary solutions. I know that sounds weird, but that's the way it is. Okay, any questions before moving on to 7? I think so, but we'll go a little faster here, hopefully. Okay, number 7, what do I need to do first? Set it equal to 0, so I'm going to subtract 4x. Okay, so we have 3x squared minus 4x minus 3 equals 0. I'm just going to, well, let's go ahead and check it. So when I multiply over, 3 times negative 3 is what? Negative 9. And my adding is negative 4. Are there any numbers that multiply to be negative 9 and add to be 4? No, because you only have 1 and 9 and 3 and 3. And there's no way of making 4 with either one of those sets of products. Okay, so this doesn't work. So we're going to use the quadratic formula. A equals 3. B equals negative 4. C equals negative 3. X equals negative b is positive 4 plus or minus the square root of b squared, which is negative 4 squared, good, minus 4 times a is 3 times c is negative 3, all divided by 2 times 3. What is negative 4 squared? Good. And then negative 4 times 3 is negative 12, and negative 12 times negative 3 is a, very good. And 16 plus 36 is 52, very good. 2 times 3 makes 6. Okay, so we write this down. X equals 4 plus or minus the square root of 52 divided by 6. Can I break 52 down? Question. Do we have a question? Okay, 52. What can 52 break down to? If you're ever not sure because it's an even number, I know it's 2 and 26. Good. And then 26 again is an even number. So I know it's divisible by 2. And so we have 2 and 13. So that means I have a pair of 2's and a 13 left over. So when I write this out now, I have 4 plus or minus 2 root 13 all over 6. Can I reduce that? Yes. What can I reduce by? 2. And remember that 2 has to go into the number in front of the group root and that number and the bottom number. So all of them can divide by 2. So 4 divided by 2 is 2. 2 divided by 2 is 1, or you can just cancel that out. And 6 divided by 2 is 3. And so my final answer is that x equals 2 plus or minus root 13 all over 3. Questions on this problem? Okay, last one. I would have you guys try it on your own, but for time's sake, we're going to do this together. What do I need to do? Is it set equal to 0? No. So we're going to subtract 4, but then I also need to do what? Yeah, FOIL or distribute. Okay, so let's go through here. X times x makes? Good. X times 2 is 2x. Negative 3 times x? Negative 3x. Negative 3 times 2? Negative 6. And then I still have a minus 4 equals 0. We're going to combine like terms. I'm going to go through and circle my like terms together so it's easy to see. We have x squared. 2x and negative 3x makes negative 1x, or just negative x, and negative 6 and negative 4 makes negative 10. Okay, my multiplication number is negative 10. When I multiply 1 times negative 10, it's negative 10. My adding number is negative 1. The numbers that multiply to be 10 are 1 and 10 and 2 and 5. Can any of those make negative 1? Nope. So that's out. Okay, A is 1, B is negative 1, C is negative 10. So when we're using the quadratic formula, what is my negative B value? 1 plus or minus the square root of negative 1 squared, because that's B squared, minus 4 times A is 1 times C is negative 10, all divided by 2 times 1. What is negative 1 squared? 1. Negative 4 times 1 is negative 4, and negative 4 times negative 10 makes a positive 40, and 1 plus 40 is 41. Good. 2 times 1 is 2. So we get x equals 1 plus or minus the square root of 41 all over 2. Can 41 break down? No, it cannot. Did you guys know the shortcut to see if something's divisible by 3? So if I want to check to see if 41 is divisible by 3, I add 4 plus 1 together, which is 5. If 5 is divisible by 3, then 41 would be divisible by 3. Is 5 divisible by 3? No, so it's not. But if this had been 42, 4 plus 2 is 6, and 6 is divisible by 3, and so the number 42 is divisible by 3. Does that make sense? Yeah. And that will work for any number. All right, any questions?